Hello everyone, let us solve this question. Here we are given that there is a metal wire of cross-sectional area 0.5 mm square, length 100 meter. It is connected to a battery of EMF 2 volts and internal resistance 1 ohm. The density of the metal is 6.35 into 10 to the power 3 kilogram per meter cube. Atomic mass of the element of the metal is 63.5 gram per mole, and the electrical conductivity is given 2 into 10 to the power 8 per ohm per meter. Further, it is said that assuming one conduction electron per atom of the metal, we have to find the drift velocity of the electrons in the wire. So, we will use the formula I equals NEAVD, where I is the current flowing through the wire, N is the number density of the electrons, the number of electrons per unit volume, E is the electronic charge, A is the area of cross section of the wire, and Vd is the drift velocity of the electrons, which we have to find. So, to find the current, we know that I equals V by R. So, to find the current, we need the voltage that is applied across it and the resistance of the circuit. Voltage is applied 2 volts, so it is given. The resistance of the circuit, internal resistance of battery is 1 ohm, total resistance will be internal resistance of battery plus the resistance of this wire. So, R equals rho L by A. This is density, let's call it D. This is resistivity, R equals rho L by A. We are finding the resistance of this wire. R equals rho L by A. Resistivity is 1 by conductivity. So resistance equals resistivity, reciprocal of conductivity, 2 into 10 to the power 8, L 100 over A, 0.5 millimeter square. So 0.5 into 10 raised to the power minus 6 meter square. Solving this, we get 1 ohm. So the resistance of this wire is 1 ohm. So the total resistance of the circuit is 1 ohm plus 1 ohm, 2 ohms. Current will be V, 2 volts over total resistance of the circuit, 2 ohms. 2 volts over 2 ohms. So 1 ampere current. So this I is 1 ampere. N is the number of electrons per unit volume. So we know the area of cross section of this wire, 0.5 into 10 to the power minus 6 meter square. If we multiply this with the length of this wire, area of cross section into length, we will get the volume of this wire. Further, multiplying the volume with the density, we will get the mass of this wire. Now this is we found out I equals 1 ampere. Now, area of cross section into length is volume multiplied by density. This is the mass of the wire. If we divide it by the atomic mass, we will get how many moles of this material is. So total mass over mass of 1 mole, 63.5 into 10 to the power minus 3 kilogram per mole, because we are doing everything in SI units. So 63.5 gram per mole will be 63.5 into 10 to the power minus 3 kilogram per mole. So this is the total mass of wire upon mass per mole. So these are the number of moles. Let's solve this. This gets cancelled. So there are 5 moles of these atoms in this wire. 5 moles means 5 into 6 into 10 to the power 23. These many atoms. Number of moles multiplied by the Avogadro's number. These are the total number of atoms. And in the question, it is given 1 conduction electron per atom of the metal. So these many atoms means these many electrons. So these are the total number of electrons in this wire. Total number of electrons divided by the volume 0.5 into 10 to the power minus 6 into 100. This is the number of electrons per unit volume, which is n. So 10 to the power minus 4, 10 to the power 27, 0.1, so 6 into 10 to the power 28. This is n. Let us substitute this n here. I, that is 1 ampere, equals n 6 into 10 to the power 28, E, electronic charge 1.6 into 10 to the power minus 19, A, area of cross section 0.5 into 10 to the power minus 6 meter square, into Vd, the drift velocity that we have to find. So 1 equals 6 into 0.53 into 1.6, 4.8, into 10 to the power 28 minus 19 10 to the power 9 minus 6 10 to the power 3 into Vd. So this drift velocity comes out to 1 over 4800 in SI system, so meter per second. They have asked it in millimeters per second. So let us multiply it by 1000. 1000 over 4800 millimeter per second. So 5 by 24, that is 0.208 millimeter per second. This is the answer, which is option C.